Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to solve a second numerical which is based on Wmax, that is maximum work done during the expansion of gas in isothermal and a reversible process. So let us do it. So this is the question that they have given to us on your screen as it is present, that 3 moles of an ideal gas are compressed isothermally and reversibly. This word isothermally and reversibly refers to that the work done in this process would be maximum. So to a volume of 2 liter. So the work done in this process is 2.983 kilojoule and at 22 degrees Celsius. So we have to calculate the initial volume of the gas. In this case, we have to apply the formula of the Wmax where volume is being involved. So, but before involving this kind of values in the substituents of like V2 and V1, first of all what we are going to do is we are going to extract the data from the given question. So let us see what are the data that we are getting from the question. So the given data is they have provided us 3 moles of an ideal gas. So in this case, N refers to the number of moles which is found to be 3. So N is equals to 3 that they have given to us. And in this case, they have said that the volume is changing to 2 liter. So in this case, the volume V2 they have given as 2 liter. And they have said that the work done in this process is, that is the W, which is given as 2.983 kilojoule. But this kilojoule can be converted into joule also. So therefore, this will be 2.983 into 10 raised to 3 joules. So this is the value of W that we have got. And they have said that this process undergoes in a temperature where it is being maintained at 22 degrees Celsius, but this 22 degrees Celsius should be converted into Kelvin, because in this case we know that in the formula that we are using a gas constant, and that gas constant also has a unit which is related to Kelvin. So therefore we will mention this temperature in Kelvin and we'll get as 295 Kelvin. So this is the value of the temperature that we have got, and based on this all things we have to calculate what would be the initial volume or what is the value of V1 that we are going to calculate. So in this process the volume V2 is given and the work which is given, because it is mentioned in isothermal and reversible process, so the work will be always maximum in this process, and hence we could apply easily the formula of Wmax. So let us see what is the formula of that. So Wmax has a formula. Wmax is equals to minus 2.303 into nRT log to the base 10 of, instead of P1 divided by P2 we will write V2 divided by V1. So let us see by substituting the values. So in this case the Wmax that they have given is 2.983 into 10 raised to 3 minus 2.303 into the value of N that they have given us is 3 into the value of R, that is 8.314, into the value of T that is given as 298, and in this case I have to calculate the log of V2 divided by V1. So you might be thinking why I have not substituted the value of V2 or V1 in this case. The thing is, it is being associated with the log. So the first thing that I am going to do is I am going to evaluate this two things so as to get what would be the value of log of V2 divided by V1, and then only it would be very much easy for us to determine by applying the antilog to it. So let us see what is the answer that we will get. So in this case I could write it in a very easy way, that is 2983 instead of 2.983 into 10 raised to 3, and again I am applying minus 2.303 into 3 into 8.314 into 298, and I'll make sure that this log to the base 10 of V2 divided by V1 should be separated. So therefore the log of V2 divided by V1, when it gets separated, so we'll get a value of, in this case we'll keep this value as it is and we'll shift this towards the denominator. So we will get minus 2983 divided by 2.303 into 3 into 8.314 into 298. So let us see what is the value that we'll get. So we are getting the value of minus 0.174. So this is the value of log of V2 divided by V1. But this is not the final answer that we are looking for it. So the final answer is we have to calculate what would be the volume of, that is, V1. So the thing that we are going to do is we are moving this log towards this side so as to get an anti-log. So we'll convert in this format, that is V2 divided by V1 will be the anti-log of minus 0.174. And if we apply anti-log to this numerical, then let's see what is the answer that we could get. So we are getting the answer as 0.669. This is the value of V2 divided by V1. So now it will be very much easy for us to calculate what will be the value of V1. So therefore we now can substitute the value of V2 as that they have provided to us. The value of V2 is said to be 2 liter. So in this case, instead of V2 we'll substitute the value of 2 into V1, so which is equals to 0.669. Therefore the value of V1 will be nothing but 2 divided by 0.669. So let us see what is the answer that we will get. So we'll get the answer as, for V1 as 2.989, which is approximately 3. We could calculate it as 3 liter. So this is the value of V1 that we have calculated using the formula of Wmax. So these are the few things that we should be going through, and we should keep a note so that nothing and no kind of mistake should happen while calculating this kind of numerical. So thank you friends for watching this video. I hope you have liked this video and you have understood how to calculate this kind of numerical. So share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.